So thank you very much for inviting me to speak at the conference. I've got half an hour. It's a little bit less than I would have liked, but let's see what we can do with that. So the Monopole Clutch, evidence of monopole-like structures and their action in cold transmutation of nuclei. What you have there is a libation disk. It is from Egypt, 3100 BC, so nearly 5,000 years ago. The two bent arms that frame the three sides of the dish are read Ka, and the word for spirit in ancient Egyptian. The loop and the knot are read Ankh, meaning life or to live. The combination could be interpreted as a phrase, life to thy spirit. And that is the text that's on the Metropolitan website where the image was taken from. Now, this is a libation disc, so you'd put water in it and you would pour it over in something or someone in a ceremony, and it's really for the sort of pharaohs and so forth. And the idea of the Ankh is that from the loop down, this symbol represents the key to all hidden knowledge, and it comes from flat all the way down to curved in various implementations. And it is just interesting that proportions nearly exactly match the type of monopoles have been observed, at least in their 2D slice by many authors. And if you actually look at the lower section where material appears to be going in or out, there is a change in the density of that, which corresponds very accurately to the change in depth of the water as it would come out of the pouring section. I have a CIA document that I came across that was released on CIA archives in January 2017. It was actually from Rabachaya Tribuna. You might know it better than I do, and it was from a news article on 16th of June 1992. And a couple of points on this. It was reported that so-called cold fusion was discovered in the United States. It could not be explained, but they were trying to find the features of fusion reactors where they couldn't be found. And then he goes on to ask, what is it, the technology that you're using? And he says, well, it's not fusion, fission, or energy from the vacuum. We are dealing with a phase transition, extracting the inner energy of matter. And it can be extracted not from water, but from, say, metal. The electron accelerator connected to the circuit turns the converter into a space propulsor. Using it, one can reach Alpha Centauri and return back to Earth in 12 years. The energy concealed in 1 kilogram of iron is quite sufficient for interstellar journey. Okay, so this, at the time in 1992, when this was published, I actually visited a switchgear conference, and next door there were a lot of Russian scientists that had lost their funding, and they were trying to sell their incredible technology, and I had a pleasure of meeting them. And so I have in the context of my mind the genuine desire for people to share their information at that time in 1992, which I experienced firsthand. And this document I first came across in 2017. And this really started a change in my thinking about what could be going on. Now, I have talked about this in other presentations, but in, I think in 2003, Leonid Oretskov at the Fondation de Broglie did an experiment where he essentially, in my view, proved the fact that strange radiation has a polar, north and south pole to it. And he used some iron 57 at 70 centimeters away from the exploding metal foils. And he had one piece of iron 57 with a north pole attached to the back of it, and another one in a different location with the south pole. And he found that he was able to change the superfine magnetic field. In the case of north, it increased it, and south, it decreased it by a similar amount compared to the control. And so for me, this shows that there are magnetic monopoles, obviously the north and south, and that they can be captured by ferromagnetic materials. And this is all back in 2003. Then there's this paper from 1983 by John G. Kramer at the Center for Experimental Nuclear Physics and Astrophysics. I've given the link there. He says, when a proton meets a monopole, consider that what will happen if a massive monopole comes very close to a proton, attracted perhaps by the small magnetic dipole field which every proton has. The quarks within the proton would have a reasonable probability of encountering the core region of the monopole. And when this happens, the quarks are very likely to forget their identity and be changed to some other flavor of quark or lepton. If this happens, proton decay becomes a near certainty. But the monopole, the cause of it all, is unaffected. It is still stuck with the surplus of magnetic flux, so it cannot participate in the decay process. I won't continue there, but essentially this catalyzes decay. Now, the first sign that I had of anything polar going on in LENR was when I had an opportunity to run the NOVA reactor, which is a microwave reactor. You put charcoal in it. It's a 2.45 gigahertz magnetron in their standard one from a microwave, but overdriven. And this produced two different pieces of material. On the left, non-magnetic; on the right, magnetic, magnetically separated. And we looked at that under the SEM with EDS, and we found the typical sort of George Ohsawa reaction products in that material here. So interestingly, it had these highly magnetic spheres. You can see them connecting to each other there. And all of the standard sort of George Ohsawa reaction products were present. And actually, this is most of the elements in your body. So it's just interesting in its own right. Now, one thing, and I've got it here, you can see the top right spectrum one is mostly sort of silicon oxide, and given the fact that it was in a quartz vibration sort of tuned vessel, it could have come from that. But the spectrum 2 is mostly iron. In fact, it's like hematite, highly magnetic material. But I don't know if you can notice, but on the big one and the small one below that, there are kind of two spots, and it's actually more clear if you look at it here, where I'm showing the carbon and the oxygen. And there's a hole on one side. It's right on the big sphere, and it's a lump on the left side of the big sphere. So it's like got two eyes, and the one at the bottom has a kind of like hole on one side and a lump on the other, and it's literally like a carbon sphere. And when I looked at this, I didn't really think too much of it. However, it kind of stuck in my mind that maybe there is some sort of poles that have got stuck to this, and they were throwing out material. And what I found over the last 3 years is that it doesn't matter which LENR system you look at, it seems to rip matter apart into alpha clusters, and it produces alpha conjugate nuclei. And if there's any kind of leftover, or it's kind of dying down, it seems to just dump a lot of carbon, which is tri-alpha, out. And so the idea that this has a sphere of carbon in one of its eyes is not surprising to me. So here we go, and this is the I have a, is it going to play here? Yes. Okay, so the top one has aluminium, magnesium, and silicon, and of course these are either side of aluminium, silicon being one side and magnesium the other. Anyway, this just got me onto the thinking about, could monopoles be involved? Now, the low-shack monopole is the type of monopole that Rödskev is wedded to. Therefore, this monopole may be considered magnetically excited neutrino. And it goes on, it is possible that such monopoles have not only electromagnetic but weak interactions. It is possible to produce monopoles in weak reactions instead of neutrinos. Now, one school of thought is that these are one and the same thing. Finally, this leads to the hypothesis that these monopoles could play a role in magnetic activity of the sun, in particular the sunspots. Now, one experiment I've worked with a lot over the last few years is the Lion experiment. And inside the Lion experiment, it has industrial diamonds embedded into an industrial diamond abrasive, like this. Here, it's a 3M diapad. I don't know if you can see that. I'm waving in front of the camera. Anyway, these are in the core, having been heated and dunked in deuterium. The interesting thing is that each reactor has a 2.5-inch iron bolt in it. And for me, this is interesting because it would allow a buildup of magnetic charge at the end of the bolt, which is right next to the fuel, up to the iron Curie point, which is 769 degrees C. And in the nickel, in the reactor, that only goes up to 353 degrees. So whereas there was a collection of magnetic monopoles by the iron 57 by Rutskev in 2002, 2003, outside of the reactor, this is trying to collect the monopoles that are produced right in the core of the reactor. And this could explain why, if you look at the area on the center of this slide, you can see that there's, the copper is not melted. That's because half of that is outside of the reactor and part of that's in the solenoid heater coil. But the bolt actually extends down to where it starts to become gray. And that's where you get these very, very interesting structures. These chiral, I would call them the left and right magnetic monopoles. And you can see them here where we have these mirrored triangles here in different locations. And so what I'm saying is that there's a concentration of magnetic monopoles both in the nickel area and in the end of the bolt. Again, this is a little bit further down, so the bolt is extending down here to just around about where that red circle is, and you have these. Oh, I'm sorry, I'll go back. How can I go back? You have these north-south structures, which I've discussed before over this area in the reactor. And it is also in this area, just where the crack in the copper oxide is up here, that we see these absolutely beautiful, beautiful strange radiation individual tracks. And for me, these are the equivalent of the birdies or the mushroom, as Perovskikov says in his paper. But they're in different orientations as it's going down the zigzag. Okay, so what I did was I took the Bogdanovich image of one of these birdies, and I did some contrast adjust to try and find out where the most dense part of the structure is. And I created a kind of 3D structure, like an inferred field structure of what that is. The disc I have there, the torus in the middle is, in my view, potentially what's creating this field structure. And then I'm overlaying that on these collections of monopoles I believe have got trapped on the inside of the quartz in the Lion reactor. And I show here that there is, when you have the same one, you have field interference, and you get material swept around and brushed off to the side, material swept around and brushed off to the side, material swept around and round. And then there's 3 down the bottom here, la, 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 la. And then in between these ones, when they're the same, because they're kind of going in different directions, you actually have these areas that are unaffected. Now, depending on the pole, and I'm not entirely certain which one's which, if you have one pole, you actually have a hole in the center. The material is not affected. If you have the opposite pole, you still have the circle around the outside, but you have an intense sort of white area where material, so one is kind of like sucking the material out, but it's not really so intense in the center, and the other one's ramming it into the surface. So here's some close-up on these potentially structures that might be causing this. So you can see the one on the left, the material is sweeping around either this way, and on this one, it's actually like it's ejecting something out, and there's one that's slightly at a different angle. Now, I've shown this before, and these are 2 structures. It's the same structure, rather, on another Lion reactor, and one is overlaying the other. And this is really a kind of magneto-hydrodynamic structure, as is this. The reason I'm saying this is because of a paper that I will come to at the end. But the wire appeared to have trapped this structure, and it's only on the outside of the reactor. And on the top of the wire, you can see a buildup of material. And in fact, that material is only on the top side of that piece of wire. And it looks like this, thank you to Magic Sound Labs. On the left, you can see the buildup of the material, and I've zoomed in closer on the right. And that is these series of crystals here that have been deposited on the top of that wire. Now, it is a Cantal wire, so you've got aluminium and a very small amount of silicon, chrome and iron in there, but there shouldn't be the calcium there. And there's this very, very high concentration of carbon, which shouldn't be in there. And so it's depositing these crystals at this top. And so what I'm suggesting is that you have these flux loops, which then join up and shift material. Now, there's an old MIT video down the left here, and you can see how the magnetohydrodynamics of this interact, leaving the structure. So I've actually got both structures there. I've got the one on the outside of the quartz, and you can see that the internal white area matches half the distance between them, and the overall area matches the larger radius, which is not the half distance, but the distance between the 2 points. Now, this is a direct connection to ferromagnetic materials. In the 2006 paper here, again by Filipov and Orutskov, they were looking at the possible magnetic mechanism of shortening the runway of the IBM K1000 reactor at Chernobyl. And this, for me, is a very interesting paper because it talks about the ability of these magnetic monopoles to bind to the oxygen nucleus. And it talks about how this made these magnetic currents in the pipes and caused the pipes to rip off the wall and eventually lead to the destruction of the reactor. So it says that theory is paramagnetic nuclei can capture magnetic charge and that these stimulate nuclear reactions. A study of the elemental composition of the post-accident fragments of graphite blocks from the 4th unit of the power plant, considerable islets of aluminium, silicon, sodium, and uranium were found within the graphite depth, although it is well known that highly pure graphite is used in the reactors for the moderation blocks. A number of eyewitnesses, including members of the government commission, have noticed that the glow observed above the ruined reactors during the first days after the accident was unnaturally colored. And he's accounting this effect due to monopoles. So what I've done on the MFMP, along with Philip Power, where we've developed this thing at nanosoft.co.nz, where you can real-time run both specific and cascade reactions using the Parkhomov reaction tables, which we've extended in many ways. And recently we've extended it with the NMR data for the elements, and we've also for the magnetic type here. So you can see for erbium, you've got this very high magnetic volume figure on the right-hand corner. Now, how does this relate to water and water being able to capture magnetic monopoles and so forth? Well, I want to talk about Amasa gas. During my time in Japan last year, I proved that the vibrator plates used in Amasa gas were producing ultrasonic frequencies, and that cavitation was being also initiated, and that this was leading to the production of strange radiation tracks. And we actually observed classic strange radiation tracks coming out of the center of cavitation spot, and that was all within the first day. The exotic vacuum object, strange radiation magnetic monopoles, is binding to both the paramagnetic oxygen in the water and oxygen itself, potentially playing an important role in Amasa gas clusters that also encapsulate and stabilize atomic hydrogen. So they've done analysis and they found these various cluster sizes of Amasa gas, and the fact that somehow that contains atomic hydrogen in there in a stabilized form. When burnt, the exotic vacuum object, strange radiation magnetic monopoles, is released by the laser excitement in the work of Porozhikov. So essentially, like he exposes with a 0.5 Tesla field water to sunlight. That is how the story goes. Whether it's coming from sunlight, I don't know. But anyway, he then uses a laser to release these same birdies that are observed by Bogdanovich and Shishkin et al. And by myself in physical form in the Lion reactor. Strange radiation aggregates in materials based on their magnetic properties, and above thresholds causes lattice failure, rapid oxidation, and transmutation. So this is a 10 yen coin that was exposed to a Mars gas. And there's this structure here, which is very similar to Aalto University's concept of a magnetic monopole, at least partway through its formation. And this structure, I analyzed the right-hand side, the more yellowy section of that, where you can see those little kind of cobblestones, as I call them. And in there were these little balls, these little plasmoids that had moved around on that surface. And they had effectively taken oxygen and fused it to sulfur. And so it would appear that it is doing LENR. It's LENR in a can. And another point on that same coin, you can see in the top center there's a classic sort of disc that looks very much like those which you've observed in Matsumoto's work and other researchers. And so I've taken the structure here, and if you can imagine, this is part the way through a surface, revealing the edge here. Then we have this particular configuration here, where that ring, the structure is coming in, and it's actually changing or removing the material. Now, it would seem that copper, it's obviously highly conductive. Both isotopes have an NMR moment quite high, and it is of the right magnetic state. It seems that copper basically disappears and transmutes readily with this technology. However, the zinc is left behind, as it were. So a very large amount of this coin disappeared, and it seems to be mostly the copper that's disappeared, and it leaves a lot of the zinc left over. But you can see in the dome of, if we're to assume that the magnetic monopole did this with its field structure or whatever, it kind of left this dome in the material. So this is just a bit of interest here. Now, in the case of the Joseph Papeb engine, changing tacks here, the exotic vacuum objects are initially generated by Tesla-based cathode ray processor and in situ using corona discharge or radioisotope. And a portion of these EVOs are destroyed in the spark discharge, releasing a wide band of electron energies that cascade ionize the Penning mixture of noble gases, with each gas taking its turn in absorbing incoming electrons. Residual EVOs are grown in this plasmatic state. Toroidal-shaped cylinder head, I'm going to skip on from that. Essentially, there was an accident. There was a very thin wire that was attached to the wall, and in infinite energy, it just says it's not sufficient to be able to contend with this power to drive this device. I believe that this was a ground drain for excess EVOs. Now, we all know lightning likes to go to ground, and ball lightning likes to find its wet path to ground. And I believe that this thin wire was actually to stabilize the reactor, to prevent exotic vacuum objects or monopoles building up in the metal structures. When the wire was removed and Fleischman decided to hold on to it, it started to build up to a threshold. Now, in the case of aluminium softens. In fact, in John Hutchinson's work, one of his colleagues was able to put his hand and leave fingerprints in aluminium by displacing it with just the pressure of his finger. So aluminium is softened, but metal, such as iron, gets to a point where it just immediately cracks. It gets to a point where it yields instantaneously. And so I believe that the actual cylinder, the aluminium cylinder block, let's assume it was that, the cylinder in there, the piston head rather, was aluminium. It became basically like a liquid, and the actual, the engine block, the head, cracked. And Fleischman, in his own account of it, this is only in Feynman's own account, he says that a cone of silvery uniform stuff shot out and turned to smoke. And so this thing exploded, but a silvery blob came out and then turned to this smoke. And I believe that that was instant oxidization of the blob of what was formerly the PAP engine cylinder. So in each of these cases, I believe these magnetic monopoles were building up, and it's something to consider for safety. In the case of Yule-Brown radiation remediation, and obviously Brown's gas has similarities with Ohmasa gas, the most startling claim by the inventor in the press is that the gas produced in his process can reduce nuclear and toxic waste to harmless carbon. This has been observed over and over again. Matsumoto in 2001, 2002 in fusion technology said whatever he puts into his reactors, most of what comes out, it doesn't matter what nucleons you put in, is carbon. I believe this is in a low pressure situation where it's not driven too hard, but it certainly matches my own observation. 1991-92, using a slice of radioactive americium, Brown melted it together on a brick with small chunks of steel and aluminium. After a couple of minutes under the flame, the molten metal sent up an instant flash in what Brown says is the reaction that destroys the radioactivity. Now, I'm going to explain that as this. That's Yule-Brown there on the right. The mild steel captures the exotic vacuum objects on magnetic monopoles, and it allows them to aggregate. The aluminium melts at 660 degrees C, and it envelops the radioactive material iron matrix. Above 769 degrees C, the iron Curie temperature, the EVOs or magnetic monopole clusters are released from the mild steel and penetrate and eat into the aluminium and remediate the nuclear waste via atomic hydrogen-bearing monopole intense thermitic-like reaction. So I believe that I have a very good understanding of what is going on. Now, Ken Scholder said monopole, or rather EVOs, can stay in metals indefinitely. 2 weeks after Piantelli had his most heat-producing reactor in 1994, which produced 70 watts, he got the thing back from the Nuclear Authority and put it into a cloud chamber. And this is the point at which he observed these protons coming out. So this is running at the temperature of a cloud chamber, let's say minus 40 degrees C, and still it's ejecting high-energy protons. I believe that there are monopole structures within it, and that is still performing nuclear transmutations. And in the case of the Parkhomov reaction tables, there are literally thousands of reactions where you have input nuclei and you end up with protons as a balancing equation coming out. And as far as I'm concerned, they don't like to stay in there. They get spat out. And I think that's what's going on. And I've talked about Adamenko's work here as well, where he is also observing a structure cold after he's run the experiment, where he's firing cesium-133 ions in, and they are basically disappearing. So again, I think that this is a case of monopole stuck in the metal. Now, this brings me then to the Solin patents. Basically, Solin was using electron beam furnace and firing kinetic electrons accelerated in a high voltage electric field. And he says, spontaneously proceeding low-temperature nuclear processes with the excitation of self-sustaining controlled chain reactions of nuclear fusion, functioning under conditions of combining electromagnetic, gravitational, and nuclear interactions in a mass of nuclear fuel, generating directly in nuclear fuel coherent radiation and superconducting currents of magnetically charged particles, obtaining a superconducting nuclear material and a nuclear fusion product with chemical elements formed in this process. So he is basically saying this is the unification of the forces. This is what I believe is going on when you get sufficient intensity of the magnetic monopoles. He uses all paramagnetic materials. That's my paramagnetic materials. That's my addition there. And he specifies it must have a low vapor pressure at its melting point. And this is so you can overload it with electrons. So you get electron bunching and can force coherence it's very well described. So he describes those elements there. And certainly in the case of titanium and tungsten, I've experienced these things with the Ohmasa gas falling apart and transmuting on a very ready basis. So over on the right, you've got the electron furnace there. A superconducting nuclear condensate is magnetic liquid metal nuclear fuel that generates energy with the generation of coherent radiation under conditions of nuclear phase transformations. Those are exactly the words in that 1992 news article. Under conditions of nuclear phase transformations in the mass of the initial product and the combination of electromagnetic, gravitational, and nuclear interactions in it. Synthesis of elements from helium. Helium is the alpha particle. I'm saying it's alpha particle conjugates that you get out of these systems to iron and other heavy elements, in particular carbon. He's already saying this in 1992. Nitrogen, oxygen, potassium, calcium, sodium, aluminium, magnesium, silicon, and iron. He says the process is accompanied by the occurrence of self-sustaining chain reactions with the participation in this process of composite particles of nuclei, protons, neutrons, external electrons, atoms, and other elementary particles inside the nuclei. Ultimately, as established by the author, a spontaneous process proceeds in the volume of the liquid bath of the metal, leading to its transition to a new aggregate state with the formation of superconducting superfluid nuclear substance and the nucleation of magnetically charged particles in it. The physical result of the process becomes a recording device and detector, and this is where it really interests me. Magnetic charges that automatically arise and are maintained in its volume lead to the decay of protons and are catalysts for nuclear reactions. So if you've got pions coming out of your decayed protons, that's going to cause all kinds of local nuclear reactions to occur. With increasing, and this was observed by Matsumoto, when parts of crystal grains inside palladium actually disappeared, and around the disappeared palladium grains, he actually had these transmutations. With increasing concentration of magnetic charges in the active medium, this intensity of course of nuclear reactions increases spasmodically. It is achieved by creating conditions for self-compression of the mass of superconducting nuclear condensate. I've observed this self-compression in echo fuel, where the structures are clustering to such an extent that they then collapse in on themselves. And this is quite similar to Matsumoto's NATO model, in my view. So, due to the formation of mobile active centers, domains in the active medium, they have the form of hollow spheres and cylinders. And I know Anatoly Klimov will have observed hollow spheres. I've observed hollow spheres. Inside them, nuclear fusion reactions occur. Magnetically contaminated particles are generated and accumulate with the generation of superconducting currents. Electromagnetic, nuclear, and gravitational forces are combined with the formation of coherent radiation. Active centers whose shells are composed of superconducting nuclear condensate rotate. This is very important for the end slides that I'm going to show you in a minute. They have a magnetic and gravitational field. Thus, active centers act as gravomagnetic rotors in local zones. In the areas of their accumulation in the active medium for superconducting current, eddy currents, and circular waves with white glow, pulsations, and local explosions, orderly directed self-accelerating mass flows in the form of cone and cylinder arise. Active centers interacting with each other move and join and then increase in their size. This process has a self-regulating and resonant character. Under such conditions, nuclear transformations spontaneously activate, propagating from central zones of the liquid bath to its peripheral regions. Ultimately, conditions for explosive compression of the active medium in the operation of the reactor occur, and it talks about large domains there. Protrusions and depressions periodically occurring on its surface correspond to the maxima and minima of the intensity of a spontaneously generated alternating magnetic field and characterize the appearance of magnetic solitons of two different polarities in the resulting magnetic superconducting liquid. The physical processes in this substance are similar to those that occur in a superfluid, superconducting nuclear plasma, neutron stars. It obeys the laws of Bose condensate and acts as a classical coherent wave. Therefore, it is detected spontaneously without chemical etching of the nuclear fusion product due to the implementation of coherent, ultra-fast explosive crystallization. It consists of many fragments of dispersed areas in the form of ordered clusters of microcrystals, which are separated from each other by voids. I'm going to show you this in my view, which I replicated in Japan last year. 2001 patent has far clearer scan electron microscope images of strange radiation and other features. This is in his patent, and it shows many of the features that he observed in his reactor. These are the various different structures that he observed and he accounted for. It's a shame there's no SEMs, but in his 2001 patent, where he looks at direct electricity generation, he actually has many, many SEMs, but I'm not going to look at that now. I just want to look at some of the features here. So in the line reactor, we have the sort of floret features that we have, which are, in my view, very similar to the shoulders bead chains. And this is these magnetic clusters self-organizing. And he also has this thing which he fixates on, which are these triangles. And we observe those triangles in many different cases in the Lion reactor. Here are the magnetohydrodynamic sort of structures here, and I've shown these earlier. And you can see that in the top left there, it specifically shows these things overlaying each other, exactly as has been observed in the Lion reactor. I believe that the Lion reactor is able to produce all, if not most, of the features of the Solon reactor, but for a few $100s, rather than having a large piece of industrial equipment. It is showing this nuclear condensate process. This is in Amasa vibrator plates, and in the Solon patent, you can see what I believe is the first images of strange radiation put into the public sphere. And if you actually look at his 2001 patent, he actually has scanning electron microscopes of what he was referring to, which are essentially strange radiation tracks. And to close out, I want to show you something with Amasa gas, which is explosive crystallization. And here we go. So what's happening in this is we are applying the gas to titanium. Titanium being paramagnetic, I believe that the burning of the Mars gas is releasing both atomic hydrogen and monopole clusters, which are being trapped in the paramagnetic structure of the titanium. And then this contacts as polytetrafluoroethylene, and you will see what happens.
It's finished.
It's had an instantaneous explosion. And the PTFE's on the left, the titanium's on the right. And here are these instantaneous crystals formed with voids, as described by Solon in 1992. And what I can tell you is that on this sample, there is all the alpha conjugate nuclei you can possibly imagine in plasmoids. And also some of these dendrites, they have fibers coming off them, and the fibers contain titanium with 3 alpha nuclei, then 2 alpha nuclei, then 1 alpha nuclei, and then it just runs out of titanium, and it puts carbon down. And the reason is it can't put beryllium 8 down, and it can't alpha, it doesn't really matter. So you just end up with a carbon fiber stuck off the end of these things. My view is that Solon's work was absolutely pioneering. I only came across his work in August, and in the previous 3 years, I observed physical manifestations of this technology going on a wide range of systems that I've observed around the world, and the samples that people have sent to me. I've just looked at things and I've gone, well, that's not right, or that's odd. And I've actually taken a macro image and then I've put it onto Google, and I've not found a similar image anywhere on the internet. And so I'm thinking, well, this must be something interesting because no one else there has got an image like this. Well, actually, what I found is that Solon's sketches are sketches of the beautiful images in scanning electron microscopy, optical microscopy, and macro photography that I've been sharing over the last several years. And where his is a large, expensive equipment, you can see the same thing occurring in this type of reactor here, which you can see here. This is essentially, you've got the reactor cores here with the iron bolt. You have in there the deuterated nickel diamond pads here. And this, for me, demonstrates all of the signature of a quantum coherent reactor, and it's for a few $100s.
Thank you very much, Bob. It was very interesting.
Так, видно?
Видно, да.
Так, Стасю видно?
Видно. Да,
Ага,
начинайте доклад.
ну, давайте тогда я попробую покороче. Прежде чем говорить о холодном ядерном синтезе, наверное, имеет смысл вообще понять, что такое атомное ядро. Я предлагаю геометрическую модель ядра, которая стоит на 3 предпосылках. Это оболочечная модель строения атомного ядра, оболочки под оболочки. Причем я считаю, что количество ядерных и электронных оболочек и подоболочек